Hello and welcome to another exam paper walkthrough. Today we are completing our summer 2022 series with the paper 3H. So this has been a really good exam series. And now that the 2023 exam series is done with, I can start working on producing walkthroughs for the last year's papers. We have a year where we keep these secure. So this is the final one of the papers. I hope you find it useful. Subscribe if you like, and we shall begin. Okay, question 1. Here is a right angle triangle. Work out the value of x. So for x, if I call it's already called x, so x is going to be equal to the square root of the hypotenuse squared minus the shorter side squared. So I missed my squares off. So to be fair, on a higher paper, I would probably type it in just like that. I wouldn't do it as 2 steps. So 8.5 squared minus 4 squared equals 12 over 5, sorry, 15 over 2, which is going to be equal to 7.5. I would leave the decimal as my answer because we've got a decimal number there, so it's consistent with the question. Question 2, work out the value of t when m is equal to minus 3. So I'm going to just write down the substitution correctly. So for whenever I substitute in a negative value, I always put it in brackets out of habit. And this is a good example why, because if I missed out the brackets, I wouldn't get the correct answer because it'll actually treat it as 3 squared minus that by orders of operation. So type it just like that in my calculator. 4 times by minus 3 squared minus 11, and that gives me 2. And looking at it, I've actually typed that in wrong. There should have been a times there, so let's just correct that. There we go, 25. Right, part B, make P the subject of the formula. So I want to get P by itself, so I'm going to minus 4 from both sides. So D minus 4 is equal to 3P, then divide both sides by 3 and switch it over. So P is going to be equal to D minus 4 divided by 3. Question 3. RST are playing a game with counters. Has some counters, so we'll call that X. S has twice as many, so we'll call that 2x. And then Tony has 6 less than S, so 2x minus 3. Minus 6, sorry. They total 54. So that means that if we add up their totals in terms of algebra, we'd have 5x minus 6, and that's going to be equal to 54. So to solve that, add 6 onto both sides, give us 5x is equal to 60. Divide both sides by 5, give us x is equal to 12. So x is equal to 12, but we weren't asked to find x. We were asked to find the ratio of r to t. So that was x to 2x to 2x minus 6. So that's going to be 24. Not 24, sorry, that's going to be 12 to 24 minus 6 to 18. So divide both sides by 12, we would get 1 to 18 over 12, which is 3 over 2. So that's going to be 1.5. So P would be 3 over 2 or 1.5. Joe is going to buy 150 rolls of wallpaper. Here is some information about the cost of wallpaper from each of 2 shops. Joe wants to buy the 15 rolls as cheaply as possible. Should Joe buy from wallpaper, sheet decor, or from style papers? We could do this one of 2 ways, really. We could find out the price per roll from each shop, because both 3 and 15 are multiples of 3 and 5 are both multiples of 15, or we could work out how much you'd pay at each shop. I think probably working out how much he pays at each shop is just as efficient in this case. So we want to do 15 divided by 3 times by 36, and then from style papers, SP, we're going to have to do 15 divided by 5 times by 70, that would be the normal price, and then we've got a 12% reduction, so that's going to be a multiplier of 0.88 to find the total price. So that's going to be my two sums. So if we type those in, 15 over 3 times by 36 gives us £180 it would cost from CD, and then from SP it's going to cost us, let's go back and edit this one, times by 5 times by 70 times by 0.88, so it's going to cost us 184 from here. So CD is cheaper, so should go buy wallpaper from, so she should buy from cheap decor, and then I'd like to include a figure here. I could do, I'll do it this way, as 180 is less than 184.80. So in my conclusion statement, what I've done there is I've included my two figures, just to make it clear for anyone marking. Question 5. The table gives information about the length in centimetres of some pieces of string. So we've got lengths and frequencies. Amos draws a frequency polygon for the information, length of string, frequency, length. Write down two mistakes that Amos has made. So normally there's one mark for a mistake with the plotting. And if we look here straight away, we've got gap of 2, gap of 2, gap of 2, gap of 3. So that flags. Let's just double check. So that should have been plotted at 45.5 and it's been plotted at 55. So that's mistake 1. Mistake 2 is normally with the axes, 0, 10, 20, 30, 40, 50, 10, 20, 30, we're missing 40. So that's my two mistakes circled. If I then describe them, the last point should be plotted at 45.5, and then my second mistake, the frequency column misses out 40. And that's my two mistakes. There may be others, but those are the main two stand out. Question 6. Jess runs 15 meters at an average speed for 15 minutes at an average speed of 6 miles an hour. She then runs 40 minutes at an average speed of 9 miles per hour. It takes Amy 45 minutes to run the same distance. So we need to work out the distance that Jessica ran first of all, work out Amy's average speed. So speed is equal to distance divided by time. So distance is going to be equal to speed times by time. So if we look at Jessica's distance, so I'll put a little j there. So her distance is going to be equal to 6 miles per hour, or 6 times by 15 minutes, which is not really awkward. Could use the time function on our calculator, but that's going to give me the fraction of an hour, plus 9 times by 40 out of 60, and that's going to give us our total distance. So that's going to be 6 times by 15 over 60 plus 9 times by 40 over 60. So double check what I've typed in there. Yeah, so her total distance is going to be 15 over 2 or 7.5 would be absolutely fine. And then if we look at Amy's speed, speed is equal to distance divided by time. Speed is equal to distance divided by time, which is going to be equal to 7.5, the distance, divided by the time. So 45 minutes is 3/4 of an hour, or 0.75 of an hour. So that's going to be 10. So Amy's speed is 10 miles per hour. And the diagram shows a rectangle, STUV, TQU and SRV are straight lines. Okay, all measurements are in centimeters. The area of the trapezium is A. Show that A is equal to. So we want the area of the grey part. Obviously the height of the grey part is going to be the same as this height, so it's going to be 4x. But this length here, well, if the total length is 3x plus 5, then this length would need to be x plus 5. And from there we can go straight to the area of a trapezium is a half of a plus b, that's the top and the bottom height, times by the the top and the bottom length. So let's substitute in a little bit, so that's going to be half of x plus 5, so x plus 10, times by the height, which was 4x. Right, if I halve the 4x straight away and bring the coefficient over, that's going to be 2x times by x plus 10, which is going to be equal to 2x squared plus 20x, which is what we were asked to show. Question 8. An electricity company charges the same fixed amount for each unit of electricity used. David uses this graph to work out the total cost of electricity he used. Work out the gradient of the straight line. What does the gradient of the line represent? So the gradient of the line then, from a real life graph, I like to take as big a triangle as I can and work out the gradient. So the gradient is going to be equal to the change in y. So m is going to be equal to, it looks like we've gone from 0 up to 16, 18, 18.4, 8, 19.6 it looks like. Yeah, 19.6. And then the change in y is 140. The gradient of that line is going to be 19.6 divided by 140, which is 0.14. We'll put it as a fraction first of all, 7 over 50, and that's going to give me 0.14. I was just looking for another point while I was sort of talking. Does that make sense? So the gradient when it was 100 should be 14, which it does fit perfectly. Yeah. What does this represent? So that represents the price per unit, the price increase per unit. I'm going to call it the increase in price per unit used. There we go. Right, question 9 expresses a power of 10. Okay, so we can tidy this up in stages. What I'm going to do is I'm going to put it in a bracket to start with. And then if I add these together, that would give me 10 to the 150 plus 90 is going to be 240. and I want that to, instead of square root, to the power of half. When I subtract them, when I divide them, I subtract the powers. So 360 minus 240 is going to give me 120. So it's going to be 10 to the power of 120 to the power of a half. And when we have the brackets, we multiply the powers. So a half of 120 is going to be 60. So it's just going to be 10 to the power 60. Liam was asked to express 12 to the power 50 to the power 2 as a power of 12. Liam wrote 12 to the power 50 to the power 2 is equal to 12 to the power 50 squared, which is 12 to the power 2,500. Liam's method is wrong. Explain why. So what I'm going to do is circle it and then explain it. 12 to the power 50 to the power 2 is equal to 12 to the power 50 times 2, not 12 to the power 50 squared. Okay, question 10. Jane bought a car 3 years ago, a new car 3 years ago. At the end of the first year, the car decreased by 12.5%. Then we give them the other two. For the next 2 years, at the end of the years, the value was, work out the value when Jane bought the car. Okay, so let's work out the multipliers. So the multiplier for the first year is 0.875. And then the next 2 years would be a multiplier of 0.9 squared. So in effect, the value of the car times by these would equal this. So the value of the car originally is going to be equal to 17,010 divided by 0.8575 times by 0.9 squared. And I would type it in just like that. Fraction button 17010, miss my 1 out, 10 divided by 0.875 times by 0.9 squared. So that's going to give me my original price of 24,000. So Raheem buys 16 shirts, 5 pairs of jeans, 3 jackets. He chooses an outfit to wear. An outfit is 1 shirt, 1 pair of jeans, 1 jacket. How many different outfits can he choose? Well, he's got a choice of 16 tops times by 5 pairs of jeans times by 3 combinations of jackets. So that would be my total number of combinations. 16 times by 5 times by 3. So we would have 240 combinations. There we go. Question 12. ABC and ACD are right angle triangles. We've given all the length there. Work out the length of AB. So we want to work out this length. So this is involving 2 sides. Well, this will involve 2 sides and an angle. So we're using trigonometry. To work this length out, though, I'm going to work this length out first. Work out the length of AB, giving your answer correct to 3 significant figures. Okay, so if I start with Y, if this is the angle that we're working with, then this is the adjacent and this is the opposite. So we're using our tan ratio. So tan is equal to opposite over adjacent. And we're trying to work out the opposite. So the opposite is going to be equal to tan times by the adjacent. So Y is going to be equal to the tan of 45, which we could use exact trig, times by the adjacent, which is 8. For the second triangle then, so I'm not going to go to my calculator just yet. For my second triangle, this is now the hypotenuse, and this is still the opposite. So we're switching our trig ratio. O and H is the sine ratio. SOH, and we're trying to work out H. So H is going to be equal to sine of the angle, opposite divided by sine of the angle. So x is going to be equal to y divided by the sine of 20. And actually, I'm going to type that in once. So I'm going to say x is going to be equal to the tan of 45 times by 8 divided by the sine of 20. So that's going to be equal to fraction button tan 45 times by 8 divided by sine of 20. And then provided I type that in right, we get 23.3904 ... So go more accurate than the question before rounding. 3 significant figures then, that's going to be 23.4. Okay, question 13. A and B are vectors such that vector A is 2 minus 3 and 3A minus 2B is 8, 17. Find B as a column vector. Okay, so I'm going to call B x over y for now. So 3 lots of A, so 3 lots of 2 minus 3 minus 2 lots of B, which I'm going to call xy for now, is equal to 8 minus 17. So that means 3 times 2 is 6 minus 2x is going to be equal to 8, and in effect minus 9 minus 2 lots of y are going to be equal to minus 17, but we'll keep that vector notation going. Right, so if we solve them both then, 6 minus 2x has to be equal to 8, so that means that 2x has got to be equal to minus 2, so x has got to be equal to minus 1. And then likewise for the y's, minus 9 minus 2y is equal to minus 17. So that means that 8 is equal to 2y, so y is going to be equal to 4. So we've got minus 1 and 4. Okay, question 14, factorise fully 4p squared minus 36. So I was initially thinking, yeah, but I have to factorise fully, right, so I can take 4 out as a common factor here. It's a bit of a deceptive question because arguably those are both square terms, but if we take 4 out first of all, factorise first, p squared minus 9, and then that's the difference of 2 squares. That's the difference of 2 squares as well, but we'd have 2's in them both. So that's going to be 4 lots of p plus 3 times by p minus 3. And if we didn't take that 4 out, we would have 2 at the start, 2 and 6, 2 and 6, and then we'd need to take 2 lots of 2 out, so that's a much easier way of doing it. Okay, part B, show that m plus, so we've got a triple bracket, can be written in the form, so it's asking us to expand the triple bracket really. I always keep my easier one to multiply out to do second, so I'd treat this as just 2m minus 5 times by 3m plus 1. I'll multiply that out first of all, so that's going to give me 6m squared plus 2 minus 15. Shall I do this 2 steps? That's going to be minus 13m minus 5. And then what I've actually done is I ignored my first bracket, so I'll bring that in now. m plus 4, m plus 4. So how you expand the triple bracket is up to you. I'm more than happy with the grid method, but I tend to do it like this. I line up my coefficients as I go. So m times by 6m squared would give me 6m cubed. M times by 13m would give me minus 13m squared. And then m times by minus 5 would give me minus 5m. Then I'm going to times everything by 4 and line up my coefficients. So 4 times 24m would give me, 4 times 6m would give me 24. m squared. 4 times minus 13m would give me minus 52m. Okay, let me finish this then. Okay, question 15. So we've got 4 points on a circle. We're told that those are straight lines. Proves that triangles APQ and triangle SRX are equal. So if we just plan this, I'm going to use angles. So those two angles are equal, those two angles are equal, and those two angles are equal. And that will prove that they are similar but not necessarily congruent. Are we given any information that distinctly clears up that they're congruent? Anything that's similar is congruent anyway. Okay, so I'm going to say that PQX is going to be equal to XRS, and the reason is that they are I'll do my reason in a bracket. Angles from same chord are equal. I use the same one for this one, so QRX is equal to XSR. So angles from same chord are equal. And then I finish it with saying that QXP is equal to SXP, as they're vertically opposite. Vertically opposite angles are equal. And then as all three angles are equal, the triangles must be similar. Okay, question 16. P is equal to 2e divided by f. P is equal to the square root of 2e divided by f. E is 6.8 correct to one decimal place. F is 0.05 correct to one significant figure. Work out the upper bounds for the value of P, giving your answer correct to 3 significant figures. So we want, so the way I'm going to do this is I'm going to set this up as I want the P upper. And to do that, I'm going to need the square root of 2 times the E upper divided by the F lower. So really, I only need the upper bound of E and the lower bound of E. So if I look at, if E is 6.8, so E has to be less than, greater than or equal to, and I only really need the upper bound, so that's going to be 6.85. And then if I do the same for F, and this time it's only the lower bound that I want, That's going to be 0.045. So that's the values I'm going to use for my bounds. So I'm going to say that P is going to be equal to the square root of 2 times by 6.85, and I want to divide that by the lower bound of F, which is 0.045. And then I'm just going to type that into my calculator. So the square root of fraction 2 times by 6.85, and I want to divide that by 0.045. So that gives me a value of, don't really need the third form, but we'll write it as an exact value. So I'm looking at 17.4483 ... So the 3 significant figures, that's going to be 17.4. Okay, question 17. The table gives information about the distance in miles that some year 10 students live from school. On the grid opposite, draw a histogram for this information. So for a histogram, I need the frequency density, which is going to be the class, the frequency divided by the class width. So we need to work out the class width. So I'll call it just CW. So we've got 1, 0.5, 0.5, 1, and 2. The frequency densities are going to be 90, 94, sorry, 96, divided by half, double 44, 8, and 24. No, sorry, 24, 6. So let me just zoom that out slightly. Okay, so if I fill in, I'll insert these as blocks to be fair. So you're going to use a pencil and a ruler for this, but I'm going to insert a few rectangles. Right, so my first one, actually I need to put on my densities first of all. 1, 2, 3, 4, 5, 6. So we're going up 6 squares, so I'm going to go up in 20s, 20, 40, 60, 80, 90. Yeah, that'll work. So my first block needs to go at 90. It needs to go 1 across. So let me just adjust that slightly. So I said I wanted to sort my scale out first of all. I should have done that before I started drawing. 20, 40, 60, 80, 100. I don't really need to go any further than that. Right, so my next block, I'm just going to cut and paste these and then adjust the shape. So my next block would supposed to be 96, which we're going to be going there. It needs to be half as wide. And it goes down to my axes. That'll do. My next one then was up to 44, and again half a width. So if I just move it straight over and then adjust the height to 44. So my next one has a width of 1 and a height of 8. So and my final one has a width of 2 now. And a height of 6. Okay, so that would be my frequency density. Yours will look similar to mine. Draw it with a pencil and a ruler, keep it nice and neat. Okay, and part B. The histogram below shows information about the distance in miles some year 11s. students live from school. The number of year 11 students who live 1 to 2 miles from the school is n. So 1 to 2 miles is n. Find an expression in terms of n for the number of year 11 students who live between 3 and 5 miles. So that's this block here. Okay, so in effect what we've got to do is, if that's got a width of 1 then and a frequency of n, then it would have a frequency density of n. This value here, in effect, a bit like calling that 1. If that was 1, that's not particularly a great thing to use. Okay, this works okay. So if we actually think about the number of squares between there and there, there's 15. So that would represent a fifth of n. So if you think 1, 2, 3, 4, 5, that would be n over 5. So it's going to be 2 times n over 5. Because we've got a width of 2 here and a height of n over 5. So it would be 2 times by n over 5. N, not pi. So 2n over 5. And again, obviously 0.4 will be absolutely fine for that, but I'm going to give it 2n over 5. Okay, question 18. Here's a prism A to R. The base is of ABCD is of the prism is a square of size 14. That's useful. That means that all lengths there will be 14 as well. Point T is such that B to C on B to C such that B to T to C is 3 to 4. Okay, so we can work out those lengths. Cross section of the prism is in the shape of a trapezium of area 147 centimeters squared. Okay, CR is 12. Find the size of the angle between SD and the base ABCD. Okay, so to do this, let me just what I'm going to do this from is I'll draw a 2D representation, D to S and T. Right, I'm going to do it by working out and I want to work out, find the size of the angle between ST and the base, so I want this angle here. Right, so let's work out this length here, which I'll call X for now, and then this, I'll call this length Y. So if we start with X, the area of a trapezium is equal to half A plus B, which is times by H. Right, so we know that that's 147, and that's going to be half of 12 plus SD, so I'll call that plus X times by H, which is going to be 14. Okay, so that would be 7, so 147 divided by 7 is going to be 21. 147 divided by 7 is going to be 21. So 21 is going to be equal to 12 plus X. So X is going to be equal to 9. Right, now we need to work out the length of Y, which is T to S, which we can do using Pythagoras. First of all, though, we need to work out C. Let me just show that a little bit more. So that was Y. We know that that length there is 14. Sorry, let's label that B, C, T. We don't know C to T though, but we know that it is going to be, we've got a ratio of 4 to 3, then T to C is going to be 3/7 of 14. So that's going to be 6. So Y is going to be equal to, or Y is going to be equal to the square root of 14 squared plus 6 squared. which is going to be equal to square root of 14 squared plus 6 squared is going to give me 2 root 58, and I'm going to leave it like that for now. So this is the opposite, and this is going to be the adjacent. I'm using the tan ratio, so tan is equal to opposite over adjacent, so the angle is going to be equal to tan to the minus 1 of, I will do it in terms of x and y for now. And then I can go to my calculator for that. So theta is going to be equal to shift tan of the opposite side, which was x, so 9 over the adjacent, which we've just worked out on our calculator to be that. So that gives us 30.5779. And we're asked for 1 decimal place, so that's going to be 30.6. Okay, question 19. Show that we've got an algebraic fraction can be written in the form where a and b are integers. Okay, so I'm going to put them all over a common denominator of x plus 2 times by x minus 2. So to do that, this fraction would need to be times by this part of the denominator, so that would be 3x, times by x plus 2 minus, and times that would become 2x plus 1 times by x plus 2, and then I've still got this minus 1, that would become minus 1, and then we multiply this out, which is the difference of 2 squares, which is also here, and we'll bring that in at this point, x squared plus 4 because of the minus there. Right, so if we try and multiply the numerator, then that's going to give us 3x squared plus 6x minus 2x squared. 4x plus x would be 5x, but it's going to be minus 5x. And then my number part is going to be 2, which would be minus 2 minus x squared plus 4. And then we'll put the denominator in the form it wants, so x squared minus 4, because that difference of 2 squares will create that. So in terms of my x squared coefficients, then I'm going to be doing, what have we got? 3x squared minus 2x squared minus 1x squared will all cancel out to 0. My number part, so let's just cross them out. My number part, then I've got 6x squared right, I've just spotted when I did this, that should have been a negative there. So I made a mistake really early on there, and I think that's the only mistake, but we'll see. So minus 6x minus 5x gives us minus 11x, and then my number part minus 2 plus 4 is just plus 2, and then that's going to be over x squared minus 4. So that's going to be my solution there. Can be written in the form where a and b are integers. Yeah, that satisfies that. Okay, so question 20. Profit made in a shop increases each year. The profit made in a shop in the year n was Pn. Given that the profit made by the shop in the next year is Pn plus 1, then Pn plus 1 is equal to A Pn plus 800, where A is a constant. The table shows the profit made in the shop in 2018 and 2019. Work out the profit predicted for the shop in 2021. Okay, so we're going to have to do 2 stages, well, to effect. I'm going to work out that value of A first of all. So in effect, I'm working out the, it doesn't really matter. So 29,600 is going to be equal to A times by 24,000 plus 800. So if I rearrange that, minus 800 So A is going to be equal to 29,600 minus 800 divided by 24,000. Now if we use our calculator for that, 29,600 minus 800, and divide that by 24,000. So we get A is 6/5. 1.2 is absolutely fine then. So then if we look at the amount made by the shop in 20,000, I'm going to use my calculator for this. So this was in effect, let's call it P0, P1, we've got P2 and P3, just to make my notation a little bit better. So in P2, I'm expecting there to be, and I'm going to use iteration to help me with this, I think. So if I put my first value in as 24,000, and then I'm going to say that, so I've got that stored as my value, so I want to do 6/5 times by my answer for my last one, and then I want to add on 800. So each time I press equals now, I should get my next value. So my next value, or P2, is 36,320, and then my next value then P3, which is the year I'm actually after, is going to be equal to 44,384. No significant figures or anything like that, so I'm looking at 44,384. Okay, question 21. Ray has 9 cards numbered 1 to 9. Ray takes at random 3 of these cards. He works out the sum of the numbers on the 3 cards and records the results. Work out the probability that the result is an even number. Okay, so just trying to think whether there's an easy way of doing this. Right, I don't think there is. So in effect, it's going to be the probability of an even. That would be an even number. It could be an even and 2 odds. It could be those are my only options starting with an even. It could be an odd, an even, and an odd, or it could be an odd, an odd, and an even. I think there are only 4 options. 1, 2, 3, 4. 1, 2, 3, 4. So probabilities of all of these added together. So probability of an even, then an even, then an even. We've got 1, 2, 3, 4 even numbers. So it's going to be 4 out of 9 times by 3 out of 9, 8 times by 2 out of 8, 7. And to that, I need to add on even, then an odd, then an odd. So that would be 4 out of 8, 9 times by 5 out of 8 times by 4 out of 7. To that, I want to add on probability of an odd. First of all, is 4 out of 9 times by 4 out of 8 times by 4 out of 7. And then odd, then even would be 5 out of 9 times by 4 out of 8 times by 4 out of 7. So in effect, I want to add all these together. They're all going to have the same denominator, which will be slightly helpful. So the denominator is going to be 9 times 8 times 7. To that, I want to add, and I've got a pair here, not that it particularly matters, 4 times 3 times 2 plus 4 times 5 times 4. Actually, that's times by 3 because we've got 3 of them. 4 times 5 times 4, 5 times 4 times 4. So we've got times times by 3. I'll put that in brackets just to show that so that there are 3 of those. And I'm going to type it in just like that. So 4 times 3 times 3 times 2 plus 3 times 4 times 4 times 5 divided by 9 times 8 times 7. That's going to give me 11 out of 22, 21. There we go. So I think that's probably the most straightforward way of doing it. I was initially thinking, would it be slightly quicker to work out how many odd numbers would have been created and then taken that away from the total? But I don't think there's much difference in that. In fact, it would probably bring in an extra calculation. So yeah, I'm happy with that. Okay, question 22. L is a straight line of equation y is equal to 2x minus 5. C is the graph of equation y squared is equal to 6x squared minus 25x minus 8. Use algebra to find the coordinates of the point of intersection of L and C. You must show your working. Okay, so in effect, this is a simultaneous equation with one linear and one quadratic. So the way I'm going to do this is I'm going to start with just manipulating L first of all. If Ly is equal to 2x minus 5, then I'm going to say y squared is going to be equal to this squared, which would be 4x squared minus 20x plus 25. Right, so now I'm going to put my two equations together. I'm going to say that 6x squared minus 25x minus 8 is going to be equal to 4x squared minus 20x plus 25. I'm going to take everything over to the left. That would give me 2x squared plus 20, so that would be minus 5x. Then minus 8 minus 25 would be minus 33. That's going to be equal to 0. I'm going to hope that this factorizes. For it to factorize, it would have to go into a bracket starting with a 2x. Then I'm looking for factors of 33, where two lots of one of them plus the other one equal 5. So if I think 11 and 3 is the obvious one, can I arrange that? So 11 take away. So 3, so 6, 11 take away 6, yeah, that works. So we would have a 3 there and a 11 there. We're going to have the minus there and no, the plus there, sorry, and the minus there, because that would give me 11 plus 6 would be minus 5. So that means my two values for x are either x is equal to minus 3 or x is going to be equal to 11 over 2. So back to my original equation up here, if x is minus 3, then y would be equal to minus 6 minus 5 would give me minus 11. And then if x is equal to 11 over 2, 11 over 2 times by 2 would be 11, take away 5 would be 6. Y would be equal to 6. That gives me my two coordinates. So I've either got minus 3 and minus 11, or I've got 11 over 2 and 6. Okay, and that brings us to the end of that paper. A really nice paper, good variety of skills there. I hope you found that useful. Before I sign off, skills map. So whichever question you've particularly found challenging, this maps the skill to it. So if, for example, you found question 12 particularly challenging, that was using trigonometric ratios to solve 2D and 3D problems. So I would recommend use that for your topic-specific revision. So that's an area that you're going to look at in a bit more detail. Thank you very much for your time. If you have any specific questions or comments or queries that you'd like me to get back to you on, please feel free to type them into the chat to this video and I will get back to you pretty promptly. Thank you very much for your time in listening to me. I hope you found it useful, and please do subscribe if you like.